Okay, so this is going to be University of St. Thomas, Math 005. This is Lesson 5, Part 1. I've set up our distribution or distributive property through a couple of our problems here. I want to just kind of jump in and we'll do our inequalities. We'll solve them. We're going to use a number line to graph the solution set, and then we're going to use our interval notation as well. Okay, so we've got a few things that we're going to do here. Let's see if we can get them done. As I say, I already distributed this through, so we're kind of on our way here. I'm going to go ahead and I'm going to subtract my 4 from both sides. So now I've got my 4x, and that's going to be less than our 4x plus 1. And the question is, what numbers does that work for? And if you stop and think about it, that's all numbers. All real numbers will work for this. So let me go ahead here and I'm going to draw my I realize it's not particularly level, but at least it's a relatively straight line. So here's my negative infinity. Here's my positive infinity. And we're saying that x is everything. This is the entire, it's everything. All real numbers will work. That's true for all real numbers. So I can say all real numbers, or I can say, for my interval notation, I can say negative infinity, and do parens on either side of those. So that one's done. Okay. Now I'm going to go ahead, I've again distributed through, I'm going to go ahead and collect what I can. I've got a 2x and a 3x, so that's going to give me a 5x. I have a 2 and a 6, that's going to get me an 8. And now I have a 5x and a minus 15. All right. Now, if I were to go ahead and subtract that 8 to the other side, I'm going to have a 5x is going to be less than 5x minus 23. And this is a contradiction. There's no number that you can have that if you subtract 23 from it, it will be larger than the original number. It just can't happen. So it's a contradiction, no solution. All right, that's as good as we're going to get. There's nothing we can do with that. All right, now in this next case, I have unlike denominators. So the first thing I had to do was take a look and say, okay, I'm going to find a common denominator. 15 looks nice. I've got a 5 here, a 3 here, and then a 15 already set up here. So 15 looks like it's a really good common denominator. So I went ahead and I did that. I've set it up so that I've got my original value multiplied by a 1 in disguise. All right, so I'm going to have a 2 times 3 is going to get me a 6 over 5 times 3 is going to get me 15x plus my 1 times 5 is going to get me a 5. 3 times 5 is going to get me 15. And my x, so now that's set. I have a strictly greater than 44 over 15. All right, now since these are all over 15, I can literally just drop that off, because if I were to have cross multiplied them, they would have canceled out. So I'm going to just literally jump to the next step. All right, this is going to become an 11, because I have my 6 plus my 5, that's going to give me 11x is going to be greater than 44. All right, when I go ahead and divide both sides by 11, my x is going to be greater than 4. And again, not particularly level, but at least it's approximately straight. All right, so here I'm going to have my 4. My x is going to be greater than it. It's strictly greater than. So that's an open dot. I'm going to draw my direction here. I'm going towards infinity. So my interval notation here is going to be 4 and infinity, and I have parens around both sides. Same kind of thing on this next one. I didn't have a common denominator, so I had to create one. That common denominator is going to be a 12, and I'm going to go ahead and get started on that. I'm just going to distribute through, make so that I've got just hopefully one set of numbers, one set of values all collected together, and then we'll solve. All right, so I've got x minus 2 times 4, so that's going to give me a 4x minus 8 plus 3x plus 3. That's all going to be over 12. Is greater than or equal to 12 is a denominator and 30 is my numerator. Now again, because these are both over 12, I can just drop those out of the whole thing. So now I'm just going to collect my like terms. I've got a 7x, a negative 8 and a positive 3. That's going to get me a negative 5. Is going to be greater than or equal to 30. If I add 5 to both sides, now I'm going to have a 7x is greater than or equal to 35. And I'm dividing both sides by 7. That's going to give me an x is greater than or equal to 5. Let me see here about getting my number. Well, that's a little too high. All right, so there's my number line. I'm going to go ahead and erase that. So here's my 5. And because I have greater than or equal to, this is going to be a solid dot. And everything is going to continue on towards positive infinity. I'm going to be increasing towards my right. So I have a square bracket of 5 and then infinity and a paren. And hopefully that gets folks a pretty good idea of how to get started on these. I'm going to do one other one here in a moment, but I want to make certain that I save this and get it up and uploaded for you.